second one.
I think we must move on here.
The second one is pupillary mechanism. And this has to do with the size of the pupil. And how can you get confused when we say that?
And remember, pupillary mechanism is about light. The person was inside the cave, he's walking out now. Now, what he did in the cave is another matter, but he's walking out of the cave into the light. What is happening? Or you come in from outside into a darker house. What is happening? Or the light is switched off, or it is dark in the room, the light is switched on. What will happen? The moment it is about light, it is pupillary mechanism. Distance, accommodation. Pupillary mechanism, light. What happens?
And I don't think they can get confused now because, I was smiling all the time because I actually did it with the grade 12 learners, and I was surprised to see how many of them have never even done that with one another, switching on a light and looking at the size of the pupil, how it changes in light and in darkness. So do it after the session and see what happens. Now, what happens during pupillary mechanism, Lorraine?
With pupillary mechanism, it is important to know that there are two sets of muscles in the iris. There are radial muscles. The radial muscles, in other words, radiating from the middle to the outside. And then there are circular muscles. Now, if you look at my fingers, these are the radial muscles. What will happen when the radial muscles contract? The pupils will become bigger. Radial muscles, they contract. There's a bigger gap here between my fingers. Circular muscles. What will happen when the circular muscles contract? Pupil will become smaller. There's a tiny hole there. Circular muscles contract. Now, there are two sets of muscles. They work together, but not at the same time. This is what we say it's an antagonistic functioning. They work together to control the size of the pupil, but when the one contracts, the other one will be relaxed. In other words, when the radial muscles contract, the circular muscles will be relaxed. And likewise. So if you look at the picture there now that's in front of you, in bright light, which one will contract? Yes, you're right, the circular muscles. To decrease the size of the pupil opening so that less light can enter the eye.
That's important, Lorraine. Less light, because it's all about the protection of the retina of the eye.
Protection against too bright lighting, it's very important. And then with the dim light or darker, you will find that the radial muscles will contract, and the circular muscles will relax, so that the pupil opening will be bigger. And you will also find, those of you who like watching CSI or those type of programs, that they look in a person's eye, that if there is a brain injury, the reflex of pupillary mechanism doesn't always work. Or when a person is on drugs, you will find that the pupil will be much smaller than or narrower than it's supposed to be, or vice versa. And if we have 2 seconds, ladies, when you look at somebody and you like that person, your pupil will be bigger. So that's why we have candlelit dinners for them.
Is that now for something to go through to the brain, or what? Well, this is when we don't
There's a question to answer.
Quite an interesting question, because now it has to do with accommodation as well as pupillary mechanism. And how do we know that? Because we know that the ciliary muscle, it has to do with accommodation, and the circular muscles of the iris has to do with the size of the pupil.
Yeah, this is to confuse you, so don't get confused.
And all I want to know is there are 4 diagrams, diagram 1, 2, 3, and 4. The top ones, of course, you can see there, it has to do with the size of the pupil. So it's small pupil, a larger pupil, and here we have a flat lens and a more convex lens. So when the ciliary muscle contract, Lorraine, they should know what happens to the lens.
Ciliary muscles contract, ciliary body closer to the lens, slack ligaments, thicker lens. In other words, it's diagram 4. And with that, and the circular muscles of the iris relax. Remember, when the circular muscles relax, the radial muscles are contracted. So which one is that? It is diagram. Yes, you're right, diagram 2. So 2 and 4 will answer this question. Do you agree?
Yeah, and you need to, definitely, and you
Got
need
it.
to work a little bit because in life sciences, you have to work a little bit
Yeah.
harder for your marks.
And you have to think.
Yeah, it's about logical reasoning.
Yeah.
Right, and then we get to the ear. Here, the ear, once again, you have to identify the different parts of the ear and you have to know all the functions of each.
Yeah, and 3 parts to the ear, the outer, the middle, and the inner ear. Outer ear with the pinna, the auditory canal, separated from the middle ear by the tympanum or the eardrum. Middle ear as well as outer ear filled with air. And
That's
then the-
important.
Yeah, it's important for proper hearing. And the inner ear filled with liquid. That's also important. Colin, let's take them through the structure and how a sound wave travels.
Yeah. I'm not going through the structures that you can find in your handout on page 23. And there you have, actually, they don't have the different, but you need to know
It's on
how,
the next page. Yeah.
but how hearing takes place. Now, sound waves, it travels. And as you said earlier, it's these sound waves come through the air. The eardrum starts vibrating, so the air wave is converted into a vibration where it has to go through the fluid, and
It's
it
now-
causes pressure.
Yeah, but now first, just in case they're confused, the airwave travels through the outer ear, auditory canal. Then it's the eardrum that vibrates. And then in the middle ear, that is still filled with air, we have the 3 auditory ossicles or little bones, the hammer, the anvil, and the stirrup. And these vibrations are transferred through those 3 ossicles. And this is the reason why it's necessary that the middles as well as the outer ear are filled with air, so that the frequency of those vibrations can be correct. Because at the moment I've got the last symptoms of a cold and my ear is blocked in my middle ear because there's too much liquid in it and my hearing is affected. So it must be filled with air. That's why you have your eustachian tube going down to your throat cavity to balance air pressure on either side of the eardrum. And then we get to the stirrup and the oval window, Colin, and that's where I stopped you, to the fluid wave and the fluid pressure.
Okay, because we're getting to that, the path of the sound wave. It's just how the sound wave in the air is converted first into vibration that amplifies
And then
sound,
to a fluid wave,
then
yes.
into pressure waves, and then converted into a nerve impulse. But here we get the whole picture.